Okay, so now we're going to be moving into our second lesson of electricity, which is what is static electricity. So it says here, static electricity, electric charges that don't continuously move, rather electrons jump from one object to another. Static electricity results from an imbalance of electric charges on the surface of an object. For example, the electric shock you get from a metal surface. So static electricity involves the jumping or transferring of electrons from object to object, guys. And it also results from when there is a great imbalance of charges. So this is when you have two objects with great amount of positive charges, so protons, and another one with a great amount of negative charges, so electrons, and this imbalance causes static. And keeping in mind, again, that it's the jumping of electrons from one object to another. This is important. So electrons always move from the more negatively charged object to the less negatively charged object. So this is because it's always trying to balance out the charges. Okay, that's the goal, to always get rid of that imbalance as much as possible to balance out the charges. So for example, if you had an object that say had 3 negatives, 2 positives, well, we know that is really like a charge of -1. And then if we had another object with, say, 3 positives and 2 negatives, we know that that is like a charge of +1. So electrons are always going to move from the more negative object to the less negative object. So this object here would be more negative. So they're going to move, they're going to jump from this object to this object to try to balance out those charges. Okay, so this is a little animation here. I'm going to wait for it to start over again. I was not ready for it to play. Okay, so it shows here that there's these positive charges, these protons on the doorknob, and then electrons picked up off the carpet. So if you were to rub your feet on the carpet, you'd get this buildup of electrons in your body. And then if you were to go to touch the doorknob, well, there's that huge great imbalance there, right? Because there's a whole bunch of protons on the doorknob, but then a whole bunch of electrons on your hand. And when you go to touch there, that's called a discharge, or a shock happens because of this imbalance of charges. Okay, so discharges. Discharges can be seen as a spark. Right? The bigger the charge imbalance, the bigger the spark. Okay, so the bigger the imbalance between charges, so the greater the difference between positives and negatives, the bigger the spark. A charge imbalance equals a discharge, like we just saw in the animation or this diagram right here. Okay, the spark there is the indication of a discharge, which is when there has been a charge imbalance. Large discharge can cause large spark and can even damage electrical equipment. Static discharge. The human body cannot feel less than 2,000 volts of static discharge. Static charge built up by scuffing shoes on a carpet can exceed 20,000 volts. A small discharge is not going to be dangerous or painful. So an example would be like removing static weather. So for example, when you take your clothes out of the dryer, sometimes they're stuck together because of the static, or in the winter when your hair gets super staticky, that sort of thing. Okay, lightning. Therefore, there is a charge imbalance between the bottom of the cloud, which becomes negatively charged, and the Earth's surface, which becomes positively charged. If great enough, rapid electron transfer occurs. this results in a discharge, which is seen as lightning. So we're going to go into more detail as to the steps involved and how lightning is produced in some future slides here. But in general, lightning is caused because a huge charge imbalance. So the buildup of a whole bunch of protons, positive charges on the Earth's surface, and a whole bunch of electrons, negative charges on the bottom of the cloud. Okay, this huge imbalance eventually results in the electrons transferring very quickly, which is the discharge or the spark, which in this case is seen as lightning. Okay, so there are different types of lightning. Sheet lightning is an example of charge imbalances from cloud to cloud, so between clouds. And cloud to ground or ground to cloud lightning is exactly what it says. That's when there is a huge imbalance between charges from the cloud to the ground or the ground to the cloud. Some interesting facts about lightning. So it kills 60 plus people and injures 400 plus people a year in the US. Lightning bolts can travel at speeds of up to 100,000 kilometers per second. They can have a voltage of up to 1.2 times 10 to the 8 volts. Every second, around 100 bolts of lightning strike the Earth, and you are more likely to be struck by lightning than eaten by a shark. Okay, so on this diagram, we're going to go over the step-by-step of how lightning is produced. So it says here, number 1, collision of ice particles cause an electric charge in the clouds. So you'll see over here in the diagram, because a whole bunch of ice particles are colliding together, this creates a charge in the clouds. Okay, and what happens is the bottom of the cloud has a buildup of negative charges. So you'll notice over here, okay, we have a whole bunch of negative charges building up at the bottom of the cloud. This induces a positive charge on the ground. So because all of the negative charges are going to the bottom of the cloud, all the electrons, this is causing an attraction to the positive charges on the ground. So we know opposite charges attract. So in this case, because we have negatives building up at the bottom of the cloud, the positives on the ground are trying to get as close to those negatives as possible. The negative charge from the cloud is attracted to the positively charged ground. Eventually, this becomes a great imbalance, and then a negative leader is joined to a positive rise, creating a channel, and lightning occurs. So you'll see here we have this lightning bolt, and this happens because of, like I said, the great imbalance between charges. This causes a discharge where a giant spark of electricity is created. And again, we see that as the lightning bolt. Okay, again, so just a quick summary. We have these negative charges building up at the bottom of the cloud, causing the positive charges, the protons in the ground, to try to get as close as possible. This results in a great imbalance of charges, and then eventually we see the spark or the discharge, which is that lightning bolt. And then this is just an animation to show exactly that. You'll see the negatives build up on the bottom. The positives are trying to get close to those negatives. Watch it one more time. And then eventually we have this great imbalance. Okay, and then those charges connect, okay, causing a huge spark, seen it and known as lightning. Okay, so it says here lightning rods. Metal rods attached to a higher part of a property, like a barn, a roof, a barn roof, a house roof, and it is attached to the ground so that lightning has a safe path to follow. These are used to minimize damage. So a lot of the time, you might see these little metal rods on top of buildings, and that lightning rod is made of metal because we know that metals are good conductors, so they allow electricity or electrons to flow through them. So when a house or a barn has a lightning rod on it, when lightning strikes, it provides a safe route for the electricity to flow or the electrons to pass through, and those electrons flow down into the ground safely, so that the property isn't damaged. And lastly, thunder. When the lightning flashes, it heats the air to a temperature 5 times hotter than the surface of the sun, causing nearby air to expand. So there's like this rapid expansion of air, and vibrate, forming the sound we hear as thunder. Okay, so when thunder occurs, the lightning has flashed. This has heated the air to a really, really hot temperature that causes nearby air to expand and vibrate. Okay, so this rapid expansion, and that forms that sound we hear as thunder.